Hello people, we are back. So I'm going to continue doing problems and properties of exponents, and I just want to show you something really quick. Something called the zero exponent property and the negative exponent property. So I'm going to go into details on this. Now you'll notice when you raise anything to the zero power, you get 1. And why is that the case? And then I'll show you what happens when you have negative exponents. Alright, so I'm going to show you something. So if we had 2 to the first power, right? And then we had 2 squared and 2 cubed and 2 to the fourth, right? 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. We know that, right? 2 cubed is 2 times 2 is 4 times 2 is 8. Multiply it by another 2, you get 2 to the fourth, which is 16, right? Now you'll notice as you move from left to right, you could say, what happens? Each time you go to the left, you could say, oh, you're multiplying by 2, right? When you're going from left to right, multiplying by 2, multiplying by 2, right? You see that? Well, what happens when you're going from right to left? Then you're dividing by 2, so on and so forth. You see that, right? So you got divided by 2, divided by 2, divided by 2. The pattern has to hold. So when you get to 2 to the 0, you divide by 2. And when you get 2 to the negative 1, you're going to divide it by 2. And when you get 2 to the negative 2, you're going to divide that by 2 again, which is going to make it 1/4, which is the same as 1 over 2 squared. Then when you divide it by 2 again, you get 1/8, which is 1 over 2 cubed. So see how when you have a negative exponent, it just flips, it switches sides, the power, and the exponent becomes positive. This works with 3s, 4s, anything. This pattern holds with anything. All right, so here we go. Let's go to our next problem. So that's why 7 to the 0 power would be 1, because anything to the 0 power is 1. And we would say something 7 to the negative 3 power would be 1 over 7 cubed, right? Which would become 1 over 7 times 7, which is 49 times 7 is 343. All right, I just came up with 2 examples really quick there. All right, let's go ahead and finish this. All right, both of these are being raised to the second power. This is a power of a quotient. So this is going to become r squared on top, and then you're going to have s to the negative 5 being raised to the second power right there. When you take a power of a power, you multiply. This is going to be r squared over s to the negative 10. Now, remember what I showed you before. See how the s is being raised by a negative 10? When an s is being raised by a negative exponent, or a base is being raised by a negative exponent, see how it went from the top? You could say this is over 1, and it went to the bottom, and the exponent became positive. So see the s to the 10, negative 10? It's going to switch sides. It's going to come on top, and the exponent is going to be positive. We could put an over 1 on the bottom. It went away on the bottom, but we'll just leave it like that. We'll have the next thing now. Let's go ahead and do the next one. You got everything over here is being squared. So you're going to get 7 squared, b to the negative 3 squared, and you have b to the 5th, and then you have b. So this 7 squared is 49. This is going to be b to the negative 6th. And this right here, that would become b to the 6th. Do you see that? Oh, and then we could add the exponents. So you get 49. That becomes b to the 0, right? And anything, no, that's a 9. That's b to the 0. Anything raised to the 0 power is 1. So that right there is 1. 49 is not being raised to the 0 power. So So you just get, that's just a 1 to be the 0 power. So you just get 49. Okay? All right, you got that one. Let's go to the next one. All this is being squared up here, so I'll go a little bit quicker. We'll say x squared, and that's y to the 4th because it's y squared squared. Then you have x to the 3rd on the bottom. You have y to the -1 over here. All right, here's a way we can think about this one. When you have a quotient of powers over here, you subtract. Well, here's the way I typically teach. You could do x, you could call this x to the -1, and then it goes on the bottom. Or we can just think about this. You have x times x in the top and x cubed on the bottom. Two x's cancel out. You're left with x's on the bottom. Right? And then for this, so you got y to the -1 right here. Right, and you have y to the 1st. That is negative exponent, so that flips. Then you got y to the 4th on top. All right, see why it flipped at a negative exponent, so you're going to end up getting y to the 5th on top, x on the bottom. All right, so we got all those done. And, all right, let me just show you this really quick, this last one. All right. So simplifying expressions involving scientific notation. So here's what we could do here on this one. We could deal with this, and we could deal with this. So on this one, you have 9.1 divided by 1.3. That's going to give you 7 times, and then this 10 to the -3 divided by 10 to the 8th. All right, when you have quotient of powers, you subtract the n from the m. So in this case, you get, that's going to give you 10 to the -3 minus 8, which could be -11. So that's a quick way you could do that one. Simplify that. You might as well. Why don't we give this two significant digits, 7.0.